Okay, let's continue on the second session of today's lecture. Here I'm going to introduce you a butterfly. This butterfly. So basic, the whole, total, the material itself. It's been well summarized in your first lecture handout, so you can go over, try to read what I have put on about this Monarch Butterfly saga. So instead of having this rather big detail, try to make it short to emphasize only some of the key points, because there is a reason why I brought up all of a sudden this butterfly in the beginning of the whole, the understanding the life science lecture. And let's see if you can agree on my personal agenda of this reason why we are going over this. So this name is Monarch Butterfly. We don't unfortunately get to see them around in this country, but if you travel to the northern part of the America or even central Mexico at the right time, then you will see plenty of them. They are all covered with entire. In some occasions, the entire sky is covered with this spectacular, beautiful butterfly, and no wonder why the name it has earned this name of a monarch. A king butterfly. So it looks great. So then in the insects, whatever, that something insect, scientific way of calling insect is arthropod, is a group. But we don't have to worry about that. Who cares about the scientific name of the group below there, or where the insect belongs to? If you know, good for you, but it's not the point. The importance is not that. And even the scientific name of the butterfly, the group where the butterfly belongs, is a Lepidopteran. Who cares? But that's a professional way of classifying all these living creatures. Okay. So who are we under this scheme, the same scheme? How do we call ourselves? Anybody? Yeah, thank you, Homo sapiens. So everybody knows that Homo sapiens is a scientific name for human. And so why do we have this scientific name on top of this common names like human, dogs, cats? And there is a reason. We can easily come up with the reason, because not everybody on Earth call human the same way human. We call it a saram, and those guys call it human, and because of that. So, but more importantly, this whole classification is called what? This phylogenetic tree. This is very, very strict. This is very stripped down version of this such classification of only animal only. Animals are only very small portion of the entire living things on Earth. But anyway, assuming, let's say, okay, for now, animals are the only living creature, then how do we divide them systematically, like reasonably? How do we classify? Just like we do if you go visit the library, and those books and the libraries are well organized so that there is a certain systematic way of that. If you have a particular book that you are interested in and then want to find, then there is a way that you can find that book. It's the same. Same thing is over here. So that's called classification, and according to this scheme. But why on earth that such classifying thing is called the phylogenetic things? What this phylogeny means? Anybody? What's phylogeny? Look it up then. We have all this cell phone. Phylogeny. What's phylogeny? Yeah, 계통 발생 is what? Can you explain 계통 발생? So phylogeny in translation, direct translation is a 계통 발생. What's 계통? What does it? Yes. Yeah.
Or relate development.
Yeah, exactly. Evolution. Phylogeny is something to do with an evolution. So it's not kind of automatic, mechanistic way of grouping things, but there is a rule. That such rule is based upon the evolution. We group them. It's not based upon the appearance. A lot of times actually it happen to be like a fall within by the similar looking things close together in the same group. Yeah, but that's the reason. There is a reason why. But actually, main concept underneath concept is we look for the reason why. Why are we grouped together? The closest relative of us is who? Chimpanzee, thank you. Yes, chimpanzee. Why? Because they look the mostly that resembled us. No, it's not. Of course, yeah, they look very much. They look the most similar to humans, but that is not the reason why chimpanzee and humans are grouped together in this so-called phylogenetic tree. Is deeper than that. That means, the reason why chimpanzee and us humans are put as the closest relative is, guess what? Can anybody guess that? What's the philosophy or principle of such things? Why? What do you mean by that human and chimpanzee are the closest relative? That means, can you rephrase? Can you explain that in another easier term? When someone say, hey, humans and chimpanzees are the closest relative, evolutionarily speaking, so to speak. Evolutionarily speaking, human and chimpanzees are the most closely related. That means, in other words, why? Why? All these points. Do you know what this point, branching point, mean? In this tree, each branching point is actually occupied by whom? The concept of common ancestor. That's the basis of dividing and grouping, common ancestor. That means human and chimpanzees, if we draw something like this evolutionary tree, probably one way of this would be like this. This all branches. And here we human, and there a chimpanzee. Doesn't look like a chimpanzee, but anyway. So then what is this? The common ancestor between human and chimpanzee. And this branch point, common ancestors are what? Why do some points are deeper in terms of this height? Some branch points are deeper than the others. What's the relevance of this length of branching point? So, in other words, what does this y-axis, what does this y-axis stands for here? Evolution, but actually more strictly speaking, it's a time. So whole this thing is an evolution thing, but the y-axis indicate the time. So if you go deep down towards the bottom, that means the past. And this is the present. So, in other words, the reason why humans and chimpanzees are called and regarded as the closest relative ever is because these two groups, share their common ancestor in the most recent past. Like, let's say here, my favorite animal, doggy. Dog? It doesn't look like dog, but it's say. So here, that distance along with the top usually represent the actual relationship, degree of relationship. So here between human chimpanzees, the space, the gap is shorter, which means they are the most closely related. But if you try to compare humans and dogs, they are wider. The gap is longer, which means dog is a kind of close to human, but it's not as close as the chimpanzee. That's what we can interpret. But then think about why dogs are placed on like more distantly related relative to human, and look at the answer is look at their common ancestor estimate. They go the branch point between dogs and human, which is indicated by what? The common ancestor existed in much longer, like in more past. Okay. So, which means human and chimpanzees got split up, evolved more recently, and that's why they are more closely related, is the concept of this whole evolution. So, if you look at this, each branching point, although it's not shown over here because it's time, the y-axis is once again is time, but each branching point there is some unknown, usually unknown, but some of the animals were discovered in the form of a fossil. So now it's known, but it's not shown at least over here. So all these common ancestors were there when they were around, and then somehow this got changed. And this changing is what we call an evolution. So what's the bottom line of this concept of evolution is, if you go all the way down according to this concept of a common ancestor, then you eventually ended up where? The very bottom over here, where everybody started from a single common ancestor. It's the concept of this biological concept of evolution. Everybody, including all these bacteria, and animal and plants, in the very beginning, there was only one single kind that we indicated as the first common ancestor, okay, whatever. And then from that one, over the time, very long time, gradually, during the course of the survival, cell division, and each individual became different. That's the result. The end result of what we can see here is in this classroom. So all of us, not to mention, let's forget about this common ancestor between chimpanzee and human, but let's just think about the very origin, the very beginning of a human, the very first human. So we believe that the very first human who got split from the common ancestor between chimpanzee and human, probably must have been a single individual. And then the single individual or whatever was able to produce the offsprings, and their offsprings became more and more abundant like this. And then nowadays we all have so many different individuals, but one thing is everybody is different. So why? In the beginning, that single individual, then we got inherited that gene, genetically speaking, the single individual ancestor. We carry that exactly the same genes from the beginning of this single individual, as we indicate a point as our whole ancestor, whether there is an according to the biblical description of the Adam and Eve or whoever they are, that must have been the one identical in terms of a genetically speaking, identical person, and that person with his or her partner kept producing, and that's why we have such a huge number of different individuals living together. But if we compare every different individual, each one of us inherit exactly the same gene, so to speak, theoretically speaking, gene from the very beginning of the first person. But why do we have so like this differences in appearances? The fact that every one of us is different outside appearance is something tightly related with our every different gene is also different. If we compare our gene from some others, and our gene will be different. Probably something difficult to grasp the concept. Let's say we produce, let's say these two individuals are identical twin. You know what the identical twins are, right? These two individuals are identical twins. So, like just freshly born, these two identical twins are just freshly born. And okay, so they are born, good. So let's celebrate their birth. So let's why don't we compare their DNA sequence? These days it's so easy to have this whole DNA sequence comparison, right? So easy, quickly. You can even do this DNA sequence comparison even in these days of technology, like within a week, it can be finished. So let's try to compare this DNA sequence. Where are you? Okay, these two identical twin DNA sequence, then what would be the end result? If we compare the DNA sequence between these two identical twins, would it be different or identical right after their birth? What do you think? Come on. Identical. That's why they are called identical twins. Yeah, they are clones. Identical twins, by definition, they are clones. You know what clones are. So genetically identical twins are genetically identical. Same. So if we have DNA sequence exam, everybody has this DNA sequence examination these days. If you're not sure, that guy is not doesn't look like my son. So let's try to have this DNA sequence. That's the reason. If this DNA sequence matches closely, then that guarantees, prove that, oh, this person is my offspring because of this genetic resemblance. So in the case of this identical twin, yeah, they are. At birth, at least, at birth, they are identical. Fine. So these two identical twins somehow lived 100 years. So after 100 years, these two identical twins, brothers or sisters, whatever, they reunited. Hey, let's celebrate. How have you been? Good. So yeah, let's try to celebrate our long lifespan. 100 years we have lived. So shall we compare our DNA sequence just like the old days when we had the first when we were born? Our DNA was identical because we are identical twins. So let's have this DNA sequence comparison once again after 100 years. What do you think? Would their DNA sequence be identical or different? If their DNA sequence are not identical anymore, then what would be the reason? Adaptation? In other words, adaptation, yes, that's true, adaptation, but have you heard of these things? Mutation? Every day we undergo some sort of a small scale of a mutation. Even if you are not smoker or anything, still there are some small portion. Mutation by definition is a change in your DNA sequence. So it will happen. It's a spontaneous thing. It will happen naturally. Mutation will occur naturally. Although some nasty chemical or ultraviolet, the lights kind of nasty things will accelerate the rate of your mutation, but mutation will occur. So here, it's only 100 years. So chances are when they have this another DNA comparison in celebration of their reunion, chances are still the overall their DNA sequence will be almost identical, theoretically speaking. However, still there is a chance. If 100 years before their DNA was 100% identical, matching, but after 100 years, it's not 100% identical, but something like 99% identical only. What would it be? What would be the reason for? Yeah, it's a mutation, stupid. So in other words, what I mean by that? This mutation will affect each different individual differently. Right? We can easily understand that. Now then, if these two identical twins somehow get extremely lucky, so they were able to live something like 1,000 years. What do you think? So these two identical twins lived their long lifespan of 1,000 years, and then they have this reunion again. And then once again, same old things. Hey, let's have this DNA sequence comparison. What do you think this time? Definitely. After 1,000 years, because after 1,000 years, like every time, gradually your DNA will change, gradually. So 1,000 years is just enough time for these two individuals have detectable difference in their DNA sequence. Let's say this is a common ancestor. Not identical parents, but common ancestors. And these two individuals were the first individual born from the common ancestor. And this time scale is not 1,000 years, but something like 100 million years or anything. Then what do you think? They're expanding the same concept and logic. Then after 100 million years, split from common ancestor, all those descendant offspring will not be the same genetically and in terms of their appearance. And that is the reason why everybody over here is different. Even though we started from one single common ancestor, originally, but over time, because change is something spontaneous. It's not something that we wanted, but change will be on us as long as there is enough time. And we are still living forever and forever. You think that your individual basis of lifespan is only something like 80 to 90 years? And think again. As long as you have your children, that means you are passing your gene on to the next generation. And so you are basically living another second round of life from the concept of your genes. Because your gene is everything. You think you are something special, but it's something that dictated by your gene. Everything is. And simply you are transferring your gene after copying exactly, and then putting into your children's gene. That's what we call what? Reproduction. Reproduction. So through this reproduction, we have been living forever, starting from the common ancestor. Yeah, everybody wants to live forever, and now you are already. You have been living forever. Strictly speaking, if you think about it, if you accept only that you are nothing but your gene, and your gene has been there forever, from the very first day. Only it may have some kind of a shuffling, just like you're shuffling your cards when you're playing cards, but still the cards are exactly the same deck of cards. And your genes are exactly identical genes, and with that, you are passing your gene on to the next generation, and then that next generation also passing on their gene on to the next generation, and here we are. But the only difference is, throughout the course, every different individual has their own way of changing, because DNA sequence change, mutation affect different individual differently. That's why we can actually, by simply comparing the DNA sequence, we can determine how close a certain individual to another individual. And that is the reason why, if you are not really sure if that particular individual is my offspring or not, then you compare your DNA sequence, and then if that DNA sequence matches, what do you mean by matching? It's not 100%, but close enough matching DNA sequence indicate that, oh, you guys have been simply separated just very shortly before. That means, oh, it's right. This person is your son. This person is your daughter. That's the basic principle of. And that same principle is also applied to this concept of evolution. So that's how we built this same phylogenetic evolutionary tree. I'm going to bring this concept of, especially this determining this relationship among different organisms in terms of this evolution by using DNA sequence comparison only. I'm going to bring up this philosophy concept once again later, but today I just spit it out so that at least you can grasp only some of this concept. And the more and more you get used to this concept, and over time, before the end of this semester, probably most of you will be okay about the correct sound concept about this evolution in terms of this, starting from common ancestor and through this changing things, and what's the basis of this changing. Okay, anyway, so grouping is something. I spent too much on the stupid concept of evolution. So anyway, there are so many. The diversity, even in terms of this whole, the single group of butterflies and moths, the diversity is everywhere. Just like we cannot miss the human diversity. Even in our classroom, everybody is different. So another manifestation of this diversity, and so is in the group of different groups of butterflies and moths. Everybody is so different. Another interesting thing about, which is only unique in the case of insect, is something called metamorphosis. Translated in, I don't want to translate into Korean because it's a kind of ugly word. So I would just simply say you look up metamorphosis in Korean, and then although it is not the same that the Korean word that you think of, but anyway, it's just ugly word, but it's changing things. Insect metamorphosis. Simply put, like you have a baby insect, larva. But this, unlike other animals, from baby strictly to adult, their shape does not change. Okay? So although it's a small miniature person, but when you grow up, still overall the body shape is exactly identical. But in the case of an insect, it's totally different. At the early stage of what we call the larva, usually these insects maintain their life in the crawling, like ugly growth form. But then all of a sudden, they change their form into another thing called pupa. What's Korean for pupa? Yeah. 그 앞에서는 주름 잡지 말라는 그 pupa. So insect has these 4 stages of it. From egg, they hatch, and larval stage, and it is totally entirely different form of life, although it's a temporary thing. But then they become pupa, and then voila, it's a beautiful butterfly, like adult insect. So this is only something that uniquely found in this group of insects and other related group, and we call it a metamorphosis. So this metamorphosis, what this metamorphosis represent, is changing. It's an extreme example of changing. Probably there must have been a reason, very good reason why insect adopted this very radical way of changing, because it is actually beneficial for their adaptation to the environment. It's metamorphosis. Because metamorphosis, by employing this metamorphosis, they can reduce, guess what? They can reduce this competition. Everybody, not only human, but including everybody, plants and other animals, they hate competition. They want to avoid, as much as possible, if there is any way, then they want to avoid too excessive competition. And this metamorphosis is a very good way of, it may sound so ridiculous, but it is a very good way of reducing the competition within self. So even this insect are trying to reduce the competition level or implemented on the self. How? By changing their body form so drastically. So in other words, when they were in the larval stage, or when they were in adult stage, or in the pupal stage, their food source is different. So they don't have to compete. How do you say they? But it is the same single individual, but still a single individual at a different stage of its life, they can utilize different source of food and some other environmental things together with. So that will have an effect of reducing the competition so that overall increase the survivability. So survival is always the top priority for everybody. In order to increase the chance of survival, and usually you have to take care of these things of what? Changing. Why? Then we call what? This type of endeavor or effort of any individual, living individual, try to change to the different environment in order to increase their chance of survival. What do we call? Is there any better, nice, elegant word describing this that I have just described uglily, like changing, trying to change in order to increase the chance of survival under given environment, changing things, and you call usually what? Yeah, exactly. Adaptation. That's adaptation. So, probably. So this change is usually involves active destroying of what's present. You destroy what you have now, destroy, and then turn yourself into something totally drastically different. It can actually, if you really think hard, it can also be applied to the case of every different humans, but usually it's really hard to point out so clearly. But in the case of insect, due to this feature of so-called metamorphosis is so obvious. Okay? But anyway, it's the same thing. The reason why insects have such a drastic way of changing, we call it the metamorphosis, is like this adaptation, another way of adapting themselves, because the change is not an option. If you do not do this, you will be out. Is something changed? Oh, I don't want to wear the same clothes. So should I actually wear different things? Kind of luxury or option? No, it is not at all. Change. You have to. You have to change. And same thing. And in your life, change is something that is not an option, but you have to always take care of things. It's something that we can take. One of the small lessons learned from after this whole living things nature. So, like turning this thing into like Munqua perspective, as this is one of the very famous book I really loved. One of my favorite books. Encountered with, I discovered it when I was very young in my college, and then changed actually my life. But anyway, that's not the point. But what's the first page, the very famous phrase of this book is what the caterpillar is in the book. Okay, the larva. The caterpillar calls the end of the world the master. Here, the master is a god. The god calls a butterfly. So the individual who undergoes a change, sometimes they don't know actually what's into it, and they may actually temporarily think that it is, oh, this is doomsday. I have to change. I have to destroy myself and then change into something that else that is not totally familiar to me. But no, don't you worry. Don't you worry, because from the distance, the Almighty God will just simply call it. That's the beautiful change into butterfly. That's what I really fell in love with this book. But anyway, so we can somehow apply this phrase into this one. Bottom line take home message is change, which is something to do with the adaptation, is not an option, but everybody has to do it. And some other very interesting features about these butterflies, and I stupid enough that I spent too much time on something like distracting points, so I didn't have enough time to cover everything. So let's jump right into, instead of this, well, let's try to go into before we dismiss our class today. Next week, I may actually have a little time spare to go over again about this Monarch Butterflies things, if I feel doing so, but I may not. But in either way, I would like you to go over what's written in the lecture handout, which is about some of the interesting features about this Monarch Butterfly, please. Over the weekend. And there are some very peculiar characteristics of this particular insect butterfly, including, for example, like one particular generation of a monarch butterfly can live extremely long lifespan. Shortly speaking, like usual lifespan of average monarch butterfly is only something 2 to 6 weeks. They can only live 2 to 6 weeks. It's very short life. But every fourth generation, fourth generation, second, third, fourth, and then next, and fourth. So every fourth generation is called the super generation. Why? Because all of a sudden, this particular intervals of a generation of a butterfly have extremely long lifespan, which every human would envy, which is how long? How long can they live? 8 freaking months. Huh? So average or usual, your father and grandfather generation lived only up to 2 to 6 weeks maximum, and then all of a sudden this grandchildren's generation can live suddenly like 8 months. Wow. How do they do that? And then it disappears. The next generation disappears, and then another fourth generation appears that can live such a long life, over 8 months. And there is a reason why. So you read about that. It's just a mystery. It's very curious mystery, and we really like to learn the magic of, so that we can apply that same thing onto the case of humans, so that we can live something like 200 or 300 years of life. Probably a lot of humans will desire to. It's not been clearly discovered, the mechanism, yet. So still, it's just kind of the homework for those scientists who are interested in these things. But this insect has display such an interesting feature. So how do they do that? Huh? Another thing is, they carry some poison. This butterfly is a poisonous butterfly. So you read about the handout and the poison, particular type of poison, and how they obtain. But probably one more interesting question is, if they accumulate this poison so that they can dispel the potential predators like birds. Once birds taste this, they vomit, and then they never touch again this monarch butterfly, or even some of the monarch butterfly look-alike. They just stay away from, oh, they are ugly. So that's very strong benefit for their survival, isn't it? But the question is, how do they obtain this poison is one thing very interesting. But one more puzzling question is, how do they survive with such a high accumulated amount of poison in their body, inside of their body, and then they don't get affected by this poison themselves? These are another things that we can think about. Actually, it's been discovered, the reason why they can survive, but I'm not going to tell you and here right now. If you are interested in individually, I can tell you, but it's not going to be on the exam. Anyway, so these different types of things, after we discover some interesting features or characteristics from nature, and then more questions will come together, which will actually attract more efforts from all different sectors of the science to pursue, to solve, or answer these questions. This one is going to be one of the potential subject of your exam, midterm exam. Write this thing down. So, this poison, monarch butterfly carry this poison, and the way they obtain the poison, is this the only example on Earth, only unique to the monarch butterfly, or are there any other similar example can you find out there? I will just leave this thing up to you, so that suddenly on the meeting exam, I will casually ask what other examples out there, and then compare and contrast. For example, compare and contrast another example that you found about this carrying the poison with that of monarch butterfly. It's probably one interesting short essay question, probably. So one potential such question. Okay. So that's and one last thing is, this monarch butterfly is now endangered, the species. It's on the verge of extinction. So if we are not lucky enough, then we may not be able to see them around after several years after or something. And then the reason, there are three reasons were there in the lecture handout. What human, it's all related with our human behavior. So how this human's behavior somehow ended up reducing the number of monarch butterflies were there. That while you are reading, probably you might want to actually pay a little extra attention to this. Is my last message. Once again, I may go over again instead of just dumping these three questions for you at the end of the question, but actually I may briefly go over the features of monarch butterfly characteristics related with these three questions next week, but I may not. So just in that occasion, then you read about the lecture handout, and then you figure them out on your own, and let's have a little discussion after if you still have some question about that. Is my right now what I think about this. So this beauty, if we get to know better, and then it becomes more beautiful, is, for example, like some of those characteristics which is peculiar and mysterious that draw some interest from scientist sector, but more importantly, what we consider the more important things in learning, whether it's Monarch Butterfly as an example or any other living creature or life itself, is probably the superficial beauty of this type of, everybody agrees on usually, oh, these are beautiful flowers. However, the approach from the mainstream of scientists about this nature's beauty is, if we somehow have access to the deeper understanding about their internal things of their life cycle or their actual biochemistry things, and usually to the scientists, it become, that object become more beautiful, especially when those learning lead them to their ultimate understanding of their form and then their function. This is actually the usual way of the reason or goal of studying the life in the life science. And actually, it is not my theory, but a long time ago, this renowned physicist, once again, it's not a biologist, but a physicist, Schrödinger, the founder of modern physics, is the one who had this initial approach. Trying to approach to in understanding some living things or mystery, trying to take the approach of physics and chemistry is one way of trying to better understand the actual real internal thing, including the mechanism and the function of life is. So once we, everybody think, oh, this is really a great looking, the symbol of the United States, the bald eagle, but always, I've never seen actually this bald eagle facing front view. Always this bald eagle portraying the side view. Do you know the reason why they always have this photo? Because of this. No, I'm just kidding aside. So let's. I want you to, every one of you, have a great weekend, and so see you next week. It's over. Today's lecture is over. See you.